Welcome to the next concept, that is, after the electric field concept we are going to discuss about properties of electric field lines. Okay, that electric field acting due to a charge. Okay, it won't be acting, it will be acting in the form of few lines. Okay, that electric field, we are assuming that it will be acting along few lines. Okay, so what are there are different properties for that electric field lines that we are going to discuss in today's session. Okay, right, let us proceed with it. So first one is regarding the properties of electric field lines. So in this video what we are going to discuss, that we'll see now. Look at this. So first, if you look into this, we are going to discuss about the introduction part, that is regarding the basics of electric field, and then we will discuss about this properties of this electric field lines, and then another important one is regarding the principle of superposition. One important one is regarding the properties of electric field lines, another one is regarding the principle of superposition. Okay, so what is that introduction part, that is regarding the basic of electric field? Let us discuss once. So previously, in the previous video, okay, if I have written there long time back, it means that it is in the previous video. Okay, right? So what did we discuss there? Actually, positive charge and positive charge will repel each other, so that's why we are calling it as an enemy. Okay, and positive charge and negative charge will attract each other, so I'm calling it as friend there. Okay, so it is based on this attraction and repulsion only we are going to discuss about our electric field concept. So for example, if you see this diagram which is there here, okay, if you see this diagram here, okay, that charge is experiencing a force of Fe. Okay, this Q0 is called as a test charge. Okay, and this Q is applying some force on this Q0. Q is applying some force on the Q0. That force we are calling it as electrostatic force. Okay, so based on this we have given the formula for electric field. Okay, what is that formula? Look at this. Or otherwise, you see here in this diagram there is a source charge, that is this, here we gave it as Q, here it is, I'm telling it as capital Q. Let us assume it as capital Q only. Okay, and here it is, what is that? Test charge. I already said in the previous video that test charge means it is the charge which is unit positive charge and which does not affect the other charges. That one we called it as test charge. Okay, and that test charge will experience some force due to this source charge, it will experience some repulsive force. Okay, right. So what is the formula for that electric field? It is given by, look at this. What is the formula for electric field, my dear? It is Fe divided by Q. Okay, where Q is the test charge, or we could have written it as Q0 there. Okay, E is equal to Fe divided by Q0. Okay, and as well as suppose if capital Q we have taken it as a source charge, and if you remember the distance we are taking it as, for example, if you take the distance as small r, okay, then what will be the electric field due to that charge capital Q? It will be equal to 1 by 4 pi epsilon naught capital Q divided by r square. Okay, so that is the formula for electric field. For example, if you want the formula for electric field in terms of force experienced by a charge, then in that case you will use this upper formula, that is E is equal to Fe by Q. For example, if you want to find the electric field due to a charge, at a distance r, then what is the formula, my dear? E is equal to 1 by 4 pi epsilon naught capital Q divided by R square. Is that okay? Right? Next, and also this spark, it is electric field. They can, okay, the sparks or lightning or thundering which you see during the rainy season, it is also due to a very strong electric field between the clouds and the earth. Okay, right. Next, so here we come to the properties of that electric field lines. Okay, first of all, electric field lines are obtained from the force experienced by a unit positive charge, that is a test charge. Okay, so for example, near to this positive charge, if you place a test charge, okay, test charge means I said it is a positive charge, then that positive charge or that test charge will experience a repulsive force, right? That means from this positive charge, it tries to move away from that. Okay, test charge will try to move away from the positive charge. So that's why the same direction of force experienced by the test charge will be taken as electric lines of force, or those are called as electric field lines. Okay, the line or the direction in which a test charge will move near a source charge, that is taken as the direction of electric field at that point. Okay, this statement is very important, my dear. You can rewind it once again and you can listen. That is, the direction of electric field is in the direction of force experienced by a test charge near to the source charge. Okay, so test charge will experience force away from the positive charge. Test charge will experience force towards the negative charge. So based on this only, the electric field lines near the charges have been defined, and here in front of you, you are able to see 4 points here. Okay, I will be explaining those points. Listen to this carefully. What is that means? For example, here what it is given there, lines of force, that is that electric field lines, they originate from positive charge. Okay, plus VE means I am representing it as positive there. Okay, so in the examination anywhere, if you are writing the statement, you have to write it as full name positive. Okay, positive charge, and they terminate on negative charge. Look at this here carefully. They are originating from positive charge and they are terminating on negative charge. That is the first property of electric field lines. Okay, first property of electric field lines is lines of force, they originate from positive charge and they terminate on negative charge. Okay, and they are, second one, they are radially outwards for positive charge. Yeah, already this is a similar to that of the first point, that is they are radially outwards. That means from positive charge it will be outwards. For negative charge they will be inwards. Okay, that also you can write. They are radially outwards for positive charge and are radially inwards for negative charge. Next one, lines of force do not intersect each other. Okay, any two electric field lines, no, they don't intersect each other. Here you are able to see many electric field lines here. Okay, are they intersecting anywhere each other? No, they are starting from positive and they are terminating on negative charge. That's it. Okay, next, for example, on that electric field line, on that electric field lines, you know, they are curved, right? They are curved and they are having a starting point and as well as ending point. So they are open continuous curves. Okay, they don't have they are not, you know, closed loops. They are having a originating point and terminating point. Okay, so they are called as open continuous curves, and those curves, they do not intersect each other. Okay, next one is, that is regarding the tangent drawn at a point on the line of force gives direction of electric field. Okay, that I'll explain you. Listen to this. So if you take a curve, okay, if you are taking a curve, for example, you take a curve something like this, okay. So I want to find what is the direction of electric field at this point, okay. At this point I want to find what is the direction of electric field, okay. So then what I'm going to do is I'm going to draw a tangent at that point. Then the tangent gives the direction of electric field at that point. The tangent gives the direction of electric field at that point. That one we call it as the direction of the electric field at that point. For example, if I want to find somewhere here, then again we are going to draw a tangent to that curve like this. That will be the direction of electric field at that point. So that is the meaning of that statement, that is tangent drawn at a point on the line of force gives direction of electric field at that point, okay. So that is the fourth point, my dear, okay. Let us move to the another two more points are there. Let us go into it, okay. So another two more points regarding these properties of electric field lines. Look at this. That is, lines of force, they tend to expand laterally and contract longitudinally, okay. These electric field lines, they tend to expand laterally, or they move away from each other laterally, and when and they contract longitudinally. Longitudinal means along the length of that electric field lines they contract each other, okay. And laterally, if you see, they move away from each other. That's what we call it as lines of force tend to expand laterally and contract longitudinally. Next point, that is, field is strong when lines of force are closer and weak when they are away from each other. For example, this electric field lines, here if you observe, they are very much far away from each other, and here if you observe, they are slightly closer to each other when compared with the other points, okay. So what I mean to say is, this electric field lines, if they are away from each other, then we say that the strength of electric field is less. At the starting we have discussed two formulas, right? E is equal to 1 by 4 pi epsilon naught Q by R square, and E is equal to Fe by Q, okay. That magnitudes will be less when these electric field lines are away from each other. That's an indication there, okay. So here if you take field lines are slightly closer to each other, then in that case the strength of electric field is greater at that point. Let us do it with an example, small example. So for example, if you see, there are few electric field lines in this way, okay. So when the electric field lines are there like this, if you observe here, if you take that electric field is EA, and here the electric field if you take it as EB, then if you observe, field lines are very close to each other at this point, whereas here they are very much far away from each other. So what we can infer from this is, electric field at point B is greater than that of electric field at point A. So that's what it means there, okay. Next, so those are the 2 points, my dear. Once again, lines of force, they tend to expand laterally and they contract longitudinally, and field is stronger when lines of force are closer, and it is weak when the lines of force are away from each other. So these are the points that are based on properties of electric field lines, okay. So that's the video for this part. Thank you.